Hi scholars, this will be our last lesson before the next test on decimal operations, and today's focus will be solving word problems that require the use of operations with decimals. So this will be a lot of review of the steps to do decimal operations, but we're going to analyze each word problem to decide what operation do we need to use to solve it. So let's look at this first situation here about rope being cut into pieces, and then we'll go from there. So here's problem 1. It says we have a piece of rope that is 5 7/75 meters in length. It's asking, if I cut this into 20 equal pieces, how long will each piece be? So what it's asking here is, if I have a rope that is 5 75 hundredths of a meter long, and I want to divide it into 20 pieces, how long would each piece be? So to do that, we need to divide 5 75 hundredths by 20. So this is a review. So right now, I want you to practice this. Divide 5 75 hundredths using long division by 20. Your answer for this question should be each piece is 2,875 10,000ths of a meter long, and you can check on the work on the right for how to do this. Make sure your work is neat on your paper, and make sure to note the placement of the decimal point and how I kept going with zeros to continue dividing until my remainder was 0. Here's another question that we're going to think about similarly. Number 2 says, if it is cut into 5/100ths of a meter pieces, how many pieces will there be? So it's saying now that we want to cut this rope into pieces that are 5/100ths of a meter long. And you see here, it's like last lesson where we have a divisor that is a decimal. So we need to make this first into a whole number to help us divide this easily. I see I have to move this decimal point to the right twice to make a whole number of 5. And if I do that to the divisor, I do that also to the dividend. So my problem becomes 575 divided by 5 to make it easier. So right now, same thing. If you can divide this out with long division on your own to practice this, pause the video and then play the video when you finish with your work. Here is the work for number 2. When you divide by 5, you get 115, and the question is asking how many pieces, so that represents 115 pieces that would each be a length of 5/100ths of a meter. Let's continue practicing. And look at problem 2 now about a tortoise. So here's another situation, and we have to ask ourselves how we're going to solve this. So a tortoise travels 945 thousandths of a mile in 3 5/10ths of an hour. So, if it moves at a constant speed, how many miles per hour is it traveling? So this word per stands for divide. So it's asking us to find miles divided by hours. So looking at our problem here, we need to make a division problem that has miles, which is 945 thousandths, divided by hours, which is 3 5/10ths. Same thing we have to think about is we have a divisor that's not a whole number. So we need to change it by moving the decimal point to the right once to make it 35. And if I do that to my divisor, we do that to our dividend as well, to move it once. And we can rewrite our problem to make sure we have the right problem, which is 9 45 hundredths divided by 35. I see a whole number divisor, so now we're good to go. So right now, if you can do again some practice, we're going to have 9 and 45 hundredths as our dividend divided by 35. Do that now on your own. Pause here and check the work after you are finished. Looking at the work here, you should get 27 hundredths miles per hour. We're going to use this number again in the next problem, number 2. So I'm going to scroll down and write that in our problem context to help us out, which is the rate of 27 hundredths miles per hour. So the question now is, at this rate, how long will it take the tortoise to travel 4 and 86 hundredths of a mile? So you may have learned in science class that if you want to find distance traveled, you do the rate times the time. And right now we don't know time. I'm trying to figure that out in this problem. I know my distance that I want to go, which is in the problem, which is 4 and 86 hundredths. And I know my rate for number 1, which is 27 hundredths. And I still don't know my time. To find my time, I need to divide both sides by 27 hundredths. So, therefore, to find my time, I need to work out this math problem here. Now, I see that there is an issue with the decimals again. So I want to make sure my divisor is a whole number. So I'm going to move the decimal place over twice in my divisor, and then also do the same for the dividend. So my math problem now is 486 divided by 27, which is easier to do. So again, work out this as practice. We're going to have 486 divided by 27. Work that out now and pause here and then check your work after you are finished. Your answer is 18 hours. So it will take the tortoise 18 hours to travel 4 and 86 hundredths miles at a rate of 27 hundredths of a mile per hour. All right, we have one more problem to do, and this one is highly aligned to your X ticket, so I highly suggest you focus on this one because we're going to do a question where we're going to analyze the situation for a track and hurdles being placed on a track. So let's read this very carefully together. There are 10 equally spaced hurdles on a racetrack. The first hurdle is 13 and 72 meters from the start line. The final hurdle is 14 and 200ths of a meter from the finish line. And the racetrack in total is 110 meters long. So we have to think about first how to visualize this just to see what's happening in this problem. So number 1 says, draw a diagram that shows the hurdles on the racetrack and label all that you know. So I'm going to help you with this by drawing this track for you. I'm going to imagine this track is just one long distance. So I'm going to do a starting point here, and it goes all the way to the end, the finish line. And I know that this whole thing is 110 meters. I also see that there are 10 hurdles. So I'm going to draw 10 hurdles with these green lines here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what we don't know is that there is some space between these hurdles that we don't know. So I'm putting question marks there because we don't know what this is. And I see that there's 9 question marks, so there's 9 spaces that we don't know. We do know, though, that the first hurdle is 13 and 72 hundredths meters away from the start line, and the last hurdle is 14 and 2 hundredths of a meter from the finish line. So this is our picture that we're going to think about in answering the question, which is, how far are the hurdles from each other? So let's think about this here, and I'm going to do a math problem for you to help work out on your paper. So I know the whole track is 110 meters. And I know the two parts of the track values. And to find what's left over, I'm going to subtract those two things. I'm going to subtract the distance from the start line to the first hurdle added to the distance from the finish line to the last hurdle. So I'm going to subtract those two pieces off. And I notice that I have 9 equal spaces left. So to find how much is one space between two hurdles, I'm going to divide this all by 9. So thinking of order of operations here, we're going to do 3 things here. We're going to have to add those two numbers first. Then you're going to subtract. And you're going to divide. So I want you now to think about how you're going to do that. Work one step at a time and show all your work, and then you're going to check the answer to this after you have given some time to add decimals, subtract decimals, and then divide decimals. Pause here so you have some independent work time. Here is the work for the last question. I put the steps in different spaces so you can see each step one at a time. I added the 2 decimals to get 27 and 74 hundredths. I subtracted that sum from 110 to get 82 and 26 hundredths. And then I divided by 9 to get a final answer of 9 and 14 hundredths. Review this problem very carefully because it's very similar to your X ticket. And then we will review for the remainder of this unit and take a test in a few days.